Hi, it's Miss House. There is a file inside of your class called Actual 3.3 and 3.4 Homework Examples. This assignment is shorter than the original worksheet that's posted, and it's what you will see in my math lab. So I want to work out examples of these problems so that you'll have a guide to get started on 3.3 and 3.4. So question number one asks us to find the average rate of change, and we're given a function, and that function is f of x equals x squared plus 2x. And to find the average rate of change, remember this is the same as the slope of the secant. So if the curve looked like this, we have to have 2 points to find the slope of the secant line. This is just regular slope. You know the slope formula, which is y2 minus y1 over x2 minus x1. But of course, in function notation, we call this a and b. Those are our x's. And these would be f of a and f of b. So if you look at the video provided by the publisher or read your textbook, the slope's going to look like this. F of b, this is average rate of change, minus f of a over b minus a. But I don't want you to be confused. These are identical formulas, just different notation. Now, one thing to remember is that they gave us x is 0 and x is 9. What they failed to give us is the y, or the f of x, coordinate of the point. So in both of these cases, we're missing our y value, and we have to use this function that they gave us to calculate what the y value is. Remember, f of x means in a function named f with an input of x, what is the y value? This is our rule, x squared plus 2x. So to find this, we have to do 0 squared plus 2 times 0. So that one comes out to be 0. So that's the ordered pair, 0, 0, because 0 went in and 0 came out. So that's x and y. Then here, for 9, we have to do 9 squared plus 2 times 9, and that's going to be 81 plus 18, and that's going to be 99. So that's the ordered pair, 999. And now we have the 2 points that we need in order to use the slope formula to find the slope. So our slope is the second y. Here's our second x. Look, 9 is bigger than 0, and we're moving from left to right when we do our x1 and y1. So it's going to be 99 minus 0 over 9 minus 0. So this is our x1, y1. This is our x2, y2. And so that's how our slope formula comes out. And that gives us an average rate of change, or the slope of the tangent, as 11. Number 2 also asks for the average rate of change. I'll just call that the AROC from now on. But keep in mind, that's the same as the slope, and it means the slope of a tangent line to a curve. So y is the square root of 3x plus 1. And this time they gave us x's again. X is 1 and x is 5. So the first thing we need to do is find our f of x, or our y values. by plugging those values in to the function. And so for the first one, I'm going to get the square root of 3 times 1 plus 1. That's the square root of 3 plus 1, the square root of 4, which is 2. And so that's going to correspond to the ordered pair x is 1 and y is 2. Input is x, output is y. Okay. Now we're going to do f of x for the second value. So that's y equals the square root of 3 times 5 plus 1. That's the square root of 15 plus 1 is the square root of 16, which is 4. So that corresponds to the ordered pair. 5 is our input and 4 is our output. So this is x1, y1, or a and f of a. This one is x2, y2, or b and f of b. So our slope formula, f of b, which is the second y, minus f of a, the first y, divided by the second x, b, minus the first x, a. So f of b is 4. That's this second point that we're using right here. This is the second point, okay? Because, again, we're moving this way on x. So if x is 1 and x is 5, this is the second one, okay? Because we go left to right. So we're going to subtract from that f of a. That's going to be a minus 2. And then our x's were 5 and 1, so that's going to be 5 minus 1. So 2 divided by 4, which of course is just a fraction that reduces to 1/2. So our average rate of change is 1/2 on this curve between x equals 1 and x equals 5. In number 3, we have a function that involves the base of e. Now remember from your past, you probably know that pi has an approximate value of 3.14. And in math, every time we see pi, and we need to think of it numerically, that's what we always think of. We think of 3.14. So don't let this e base confuse you. E is similar to pi. It's a number that's fixed, and it's about 2.71828. And I'm going to go 5 places because it asks us to do 4 decimal places in our answer. It might even be safest to go maybe even 6 places, and you can find that on your calculator by pressing second ln for natural log, and then this e pops up like this, and we want just a single e to the 1, so you have to put a 1 in there before you hit the equal key. Okay, and that's going to tell you the value of e. Now you can just use that e button when you're doing your calculations, or you can use this estimate, either one. As long as we go several places out, we should be able to get it to MyMathLab's specification. For me, I'm not going to be too worried about a rounding error that's off by a tenth or 100 or anything, but MyMathLab will frustrate you if you don't pay attention to that. So they gave us x is -2 and x is 1, and we're supposed to find the rate of change between those 2 points. And again, this is the average rate of change, okay? Not just the instantaneous, or what we call just the rate of change, the average rate of change. Okay, so we have to find f of -2, which is going to be e to the -2. Well, that's 1 over e squared. And at x equals 1, f of 1 is e to the 1, which is just e. So remember, 1 is our second. We're moving this way, right? And so negative 2 comes first. That's our x1. And 1 comes next. That's our x2. So in our denominator, we're going to have x2, 1 minus negative 2. And of course, in the function notation, this would be b minus a. Simplifying that, that's 1 plus 2, so that denominator is 3. Now, in the numerator, I have to take the second y, and this is our second y, so we'll write this as f of b, and this as f of a. So we've got to do e minus, we can do e to the negative 2 in our calculator, or 1 divided by e squared, it doesn't matter. Okay, so I'm simply going to enter that in my calculator because they asked for a decimal answer this time. So I don't have to worry about simplifying it or anything. So second ln e to the 1, close my parentheses, minus second ln e to the negative 2, close my parentheses, and hit enter. That comes out to about 2.58295. And I've rounded it to 5 decimal places so that we can be accurate to 4. I have to divide that by 3, and I get an approximate value for this answer, and this is also approximate because we approximated the e value, of 0.86098. Again, it's approximate. And I'm supposed to go to 4 places, so this 9 bumps up to a 10, 0.86, and there's a 10, and of course that's equal to 0.861. You can leave off that 0 and be okay. So don't let the e freak you out. Just remember, e is like pi. It's just a number. There's where e comes from, it's the limit as x approaches infinity. Now that we've talked about limits, 1 plus 1 over x to the x. So we could actually fill in some numbers here and look at that limit by doing a table like we've done on other problems, and this is going to come out to about 2.718281, which has been given the name e in mathematics. But don't worry too much about this. Okay, that is not something that you have to know. What you really need to know is that e is about 2.71828 and how to find it on your calculator. Number 4, suppose the position of an object moving in a straight line is given by s of t equals 2t squared minus 7t minus 8. Okay, so this is a position of an object moving in a straight line, and t is time. They don't really tell us that, but they do say that we want to find instantaneous rate of change, or in this case, since it's the velocity, instantaneous velocity at time equals 3, and they don't say, so I'll just say 3 seconds. Okay, they didn't give us a time unit, but it's a time 3, as they say. Now, this is completely different, okay, completely different from average rate of change. This is the instantaneous rate of change. So there's some relationship, but you've got to use a different formula. The instantaneous rate of change, we'll call it the IROC, instantaneous rate of change, is given by a limit as h goes to 0 of f of x plus h minus f of x divided by h. Now a little background on this formula. This is a parabola. It looks something like this. Okay, I'm not worried about exactly where it's located in the plane or anything. I just know that if it has a t square in it, it's going to be a U shape. Okay. If we were finding the secant, we would want to know the slope between 2 points. So this would be x, and we're going to move over a distance of h. So this one would be at x plus h. So for example, if this was at 3 and we're going to move over 5, the second one would be at 8. All right? But that's a secant line because it's through 2 points on the curve. So what we do when we are finding the instantaneous rate of change is we take this first point and we let h go to 0. That is the distance between these points. So I'm going to move this point all the way back to this point. So now I'm only at a single point, and my line can then be a tangent line because it's going to touch it just at that one point. So when we let h, the distance between our two x values, go to 0, then we're looking at a tangent line, and that's an instantaneous rate of change. Now, a real-life application of this might be if you're traveling to a city and it takes you 2 hours to get there and you went 120 miles, 120 divided by 2 would be an average of 60 miles per hour. But you know, when you travel, sometimes you go faster than 60 and sometimes you go less than 60. So if you're stopped by a state trooper going 80, that 80 miles per hour would be your instantaneous rate of change because he clocked you at one specific moment in time. So instead of an average, we're looking at this single specific moment in time. And so that's sort of the nuts and bolts of where this formula comes from, right? Because if you've got x and x plus h, this would be f of x and f of x plus h, right? And so this would be your first y and your second y, and this would be your first x and your second x. So that's the typical slope formula. Now, when you subtract your y's, when you subtract your x's, your second x, x plus h, subtract x, you end up with just h. That's where this denominator comes from. Okay, it is x2 minus x1, but we just write it as h. And then the difficulty comes in is we can't just plug a 0 in here, so we have to do some algebra to simplify our expression and be able to find the instantaneous rate of change. So, what does the formula tell us to do? Well, it tells us we have to find first f of x plus h. Now, this is like any function evaluation, wherever, and in our case, it's going to be s of t plus h, right? Because our input value is a t, not an x, and the name of our function is s. Same thing. We're just going to put in a t plus h or an x plus h. It's fine if you put an x plus h. Just know that x and t are interchangeable. So I'm going to say 2 times x plus h squared minus 7 times x plus h minus 8. And again, I could put t plus h. At the end, x or t, whichever one you use, is just going to be a 3. We get ready to substitute. Now, the tricky part here is this x plus h squared. It's the thing that folks tend to miss. This is not x squared plus h squared. This exponent, this 2, means you need x plus h twice, and that means that you need to use a full rule. So it's x squared, that's my first 2, plus xh, that's my outer 2, plus xh, that's my inner 2, plus h squared. So every time you do this, when it's a square, okay, it's a square like this, it's going to be x squared plus 2xh plus h squared. You're going to lose that 2xh if you just square each part. So I'm going to go back over here and I'm going to put 2 times x squared plus 2xh plus h squared. Then it's minus 7x minus 7h minus 8. Distribute the 2, 2x squared plus 4xh plus 2h squared minus 7x minus 7h minus 8. Now, all I have done is f of x plus h. I haven't done the minus f of x or the divide by h, so I have to do all of that. So let's talk about minus f of x. So here's my f of x plus h. Now I'm going to do minus f of x. And then I'm going to combine these, okay, because it says combine them in this numerator. Well, what is f of x? Well, it's 2x squared, okay, minus 7x, and I'm using x instead of t, minus 8, but it's the opposite of all those, so it's a negative and a positive and a positive. And so what happens is, once I do this subtraction here, anything from the original function is going to be removed, because that's what this says. Right here it says take away everything from f of x, or s of t, the original function. So those are all gone. That leaves me with 4xh plus 2h squared minus 7h. And at this point, all terms should have an h. And if they don't, you know you have a problem. Anything without an h has to be removed. That's what this says, just the plain f of x. But everything that's left should have an h. And then in my last step, I'm going to divide by h, right? That's what this says. It says divide, not there, over here. It says divide by h. Okay? So divide by h, divide by h, divide by h, and I get 4x, because these cancel out, plus 2h, because h into h squared leaves an h, and then minus 7, because these cancel out. So now, okay, now I can actually do the limit as h goes to 0 of what's left after I did all that evaluation. 4x plus 2h minus 7. I can substitute in, okay, as long as it doesn't cause a 0 denominator. So that's going to be 4x plus 2 times 0 minus 7. That's 4x minus 7. Now this is the formula for the slope of the tangent. In other words, it's the formula for the instantaneous rate of change. And what did they tell us that t or x, remember we're using x instead of t, just put a 3 in there. So it's 4 times 3 minus 7, 12 minus 7 is 5. So that means that our instantaneous velocity at time equal 3 seconds is 5. And we don't have any units. It might be feet per second or miles per second or kilometers per hour. We don't know, but we know that at this particular point 3, the instantaneous rate of change is 5.